Hello students, today we'll start with composition of functions. Composition of functions. Suppose if we are having two functions, then question arises that can we combine these two functions to form a new function? Yes, we can combine these two functions to form a new functions. How? Suppose we are having a function f such that a to b and a function g such that b to c. If we send all the elements that x belongs to a to c, then this is known as composition of functions. So by this operation, composition of functions, we can send the elements x which belongs to a in two steps to c. By pictorial form, we can see that suppose this is set A, this is set B, this is set C. Now what is f? F is connecting, associating the elements of A to elements of B. This is F and this is G. G is connecting the element of B to element of C. So by the operation composition of functions, we can connect the elements of, this is G circle F, G of F, to the elements of C. Already we are aware that what is function? Function is a rule, law or association of elements of one set with the elements of second set. So here if we are having three sets, that means the function f combining first A and B two sets, and function G is associating or connecting elements of B with elements of C. Then G of F, composition of these two functions G of F, connects the elements of A to elements of C. So how we can define composition of function? If f such that a to b and a function g such that b to c, then the composition g of f such that a to c means composition of these two functions, that is g of f, is going to connect the elements of A to elements of C. So this is in two steps. First we connected A to B, then B to C. But if we connect A to C, then this is known as g of f. So g circle f or g of f x, we can write it as g of fx. G of fx. This is possible if range of first function is a subset of domain of second. Range of function f is a subset of domain of G. But for real valued function, we are going to study at this standard real valued function. What are real valued function? The functions whose domain and codomain are the subsets of real number. So in the real number, this may also works if RF is not a subset of DG. But what is the condition for that? For that, RF intersection DG should not be a null set. That means the foremost condition for the composition is RF is a subset of range of function f must be the subset of domain of function G. But for real valued function, it may works If this is not the subset of this, but for that the compulsory condition is range of function f intersection domain of function g should not be equal to 5. That means these two sets may not be the disjoint sets, and it will works if they are not disjoint sets. Then it will works only for those elements of A which are having F image in B, So this is the composition of functions. We have seen in compositions that g of fx, instead of the variable, we are going to substitute the functions at the place of variable in second function. We will take example, then it will be more clear, more easy to us. For example, we are having two sets or two functions, not sets, functions. Fx is equal to 2x plus 1, gx is equal to x minus 1. Now we want to find out the composition of two functions, these two functions. What is g circle f, g naught f, or g of f x is equal to g of fx. That means in g, instead of x, we have to substitute the value of fx. So what is this? 2x plus 1 minus 1. What we have done? G of fx. Here, instead of x, we have to substitute this value of fx. So what we are getting over here? That is 2x plus 1 minus 1, this cancelled. So it is equal to 2x. And what would be f of g of x? So this is f of gx. That means instead of x, we have to substitute the value of gx. So 2x plus 1, 2x, instead of x, we are going to substitute the value of x minus 1 plus 1. So this is 2x minus 1 plus 1. So this is equal to, here we did it wrong. This is 2x minus 2 plus 1. Now when we will combine these two terms, then what will happen? 2x minus 1. So we are getting f of gx is equal to 2x minus 1 and g of fx is equal to 2x. So it is very simple to understand what is composition. If we are doing the composition of two functions, then we are going to connect the elements of domain of first function to the codomain of second function. So we have seen that if we will do g of fx, that means instead of x, we have to substitute the value of fx. And similarly, when we are going to do f of gx, then instead of x in fx, we will substitute the value of gx. Let us start to do few problems from Ncert book. That is, first question, let f such that 1, 3, 4 to 1 to 5 and g such that 1 to 5 to 1, 3 be given by 1, 2, 3, 5, 4, 1. This is function f, and function g is equal to 1, 3, 2, 3, 5, 1. Write down g of f. So, see, we have seen this is the composition of two functions. When we do the composition of two functions, then the resultant function will have the domain as the domain of first function and codomain as the codomain of second function. We have seen it because if f such that a to b, g such that b to c, this implies g of fx, or simply we can say g of f such that a to c. We have seen it. Now, what is domain of first function? 1, 3, 4. What is d of f? 1, 3, 4. What is R of F? R of F. R of F. The second element of all ordered pair is the range of the function. So what is R of F? This is 2, 5, 1. What is D of G? Domain of second function. What is the domain? 1, 2, 5. What is the range of second function? The set of all second element of ordered pair. So that is, what are the second element? 1 and 3. Now see, what is the condition for this? R of F must be a subset of domain of G. This is the condition. So see here, RF is equal to DG, or subset and equal to DG. Therefore, what is G of F? Now G of Fx is defined. So what is G of F? For G of F, the domain of this composite function will be domain of the first function. So that is G of F1. So G of F1. Now see, if you will substitute, what is the value of F1? Here. Because F1 is equal to 2, F3 is equal to 5, F4 is equal to 1. We have seen, if we, what do you mean by this order pair? This is the element of domain, this is the element of range, and that means in function f, if we will substitute the value as 1, what we will get the image? We will get the image as 2, and then when we will value as 3, then we will get as 5, and when we will substitute the value of x as 4, then y will be 1. So G of F1, F1 is equal to 2, that means G of 2. What is the value of G of 2? G of 2, similar way. And what is the value of G of 1? That is equal to 3. What is value of G of 2? That is equal to 3. And G of 5 is equal to 1. So similarly, G of 2, what is the value of G of 2? That is 3. Then G of F, second element, domain 3. What is the value of G of F3? That is G of F3. What is the value of F3? F3 is equal to 5. So G5 is equal to 1. And third element, what is third element? G of F, third element of domain, that is 4. So this is equal to G of F4. What is the value of F4? F4 is equal to, we have seen here, F4 is equal to 1. So this is G of 1. What is the value of G of 1? 3. We have seen that when we'll do the composition as G of F, then instead of x in G, we will substitute the value of Fx. So what is the answer for this question now? G of F is required from us. So what is G of F? Therefore, G of F is equal to, what is the set? First order pair. The element of domain is 1. What is its range? 3. Similar way, the second element of the domain is 3. What is the range? When we have put the value of G of F instead of x as 3, then we are getting 1. And what will be third element? Third element of the domain is 4. Then for 4, what we are getting for 4? We are getting as 3. So this is our answer. G of F is 1, 3, 3 1 and 4 3. That means we have done, when we have done the composition of these two functions f and g, then we are getting g of f as 1 3 3 1 and 4 3. Now we will try second problem, that is fourth problem of this exercise. Here fx is given as fx is equal to 4x plus 3 by 6x minus 4. X is not equal to 2 by 3. Why we have written this as 2 by 3? Because if instead of x we will substitute the value of 2 by 3, then what will happen? 3 2 is 6, 2 2 is 4, 4 minus 4 is 0, and division with 0 is not possible in mathematics because this is undefined. Already I explained it. Now come to the question. We are required to find out f of fx. That means f of fx. In fx, where we are having x, we have to put the value of fx. So now substitute the value. See here, as we are getting x in the numerator 4x, then instead of x we have to put the value of this whole function because we are doing f of fx. So now this is 4x plus 3 divided by 6x minus 4 plus 3 whole divided by 6 into 4x plus 3 divided by 6x minus 4 minus 4. Now when we will open the brackets, then what will get from here? 16x plus 12 by 6x minus 4 plus 3. Similar way, 24x plus 18 whole divided by 6x minus 4 minus 4. This is minus 4. Now we can take LCM of numerator, that will be 6x minus 4. So we'll get from here 16x plus 12 plus, we have to multiply this 3 with this, then it is 6 3 18x minus 12 whole divided by, similarly we can take the LCM of denominator, and what we will get from here, that is 24x plus 18 minus 24x plus 16. So this is equal to, in the numerator this cancelled with this, and in the denominator this cancelled with this. We are getting 34x whole divided by 6x minus 4, and when we will multiply this, then what will happen? It would be reciprocated, that is 6x minus 4 upon 34. So this cancelled with this cancelled with this, and we are getting it as x. So f of fx we have found out, we have calculated the value of this f of fx, that is equal to x. Now we are required to find out what is inverse of this function. Now we have seen f of fx, because f of fx is equal to x is equal to ix. It is an identity function. Therefore, or this implies f inverse is equal to f. Why? Because existence of inverse we have seen. If you will multiply any function with the any other function and we are getting identity element, then it will be existence of inverse. So therefore f of fx is equal to x, and that is the identity function. That means f inverse is equal to f. Thank you.